I'm going to review for you the definition of a derivative. It's also known as a difference quotient. All right. There are two that you've learned and really used. First one being the limit as h goes to 0 of f of x plus h minus f of x all over h. This is the one that we use if you want to talk about the derivative coming in from the left-hand side. We say the limit as h goes to 0 from the left side. And the rest of the definition is exactly the same. Or if you want to say the limit as h goes to 0 from the right means the derivative coming from the right side of the function. Alright, so that's the one that you're used to using. On the test you won't have to physically use it. You'll have to know that it's being used and understand that this is actually the derivative. Therefore, if I wanted to find the derivative at 2, I would be looking at the limit as h goes to 0 of f of 2 plus h minus f of 2 all over h. That's one of the definitions. The other definition, the alternate definition, is the limit as x goes to a of f of x minus f of a all over x minus a. And there actually is a third one. You didn't use it much, but they may ask you just to identify the third one. That's the limit as h goes to 0 of f of x plus h minus f of x minus h all over 2h. So those are the three. And every single one of them, I can say f prime of, this one would be f prime of a, and this would be f prime of x. So all of them find the definition of a derivative. They actually find the derivative. So the problem that you're going to do is this guy. It looks a little different, and you're essentially evaluating the limit, but you want to do this by not actually having to do a limit. So that's my little hint. Press pause now to do the problem, and then when you're done, you can kind of fast forward to the answer to see what I get. So I'm going to move this over a little bit. This has to be the derivative of the function. And what you need to do is figure out whose derivative it is. So what I'm going to do is write the definition right underneath it. And actually, I'm even going to write it with A's. And if you take a look at this, you'll notice that everything kind of lines up. And what I mean by that is, you see this f of a, you have to understand that that's f of a, and that's why the 1's there. This f of a plus h comes from here. So what I tell students is, you always identify what the a value is, and the easiest way to identify is where the h is, because it doesn't simplify. So this right here has to be the a. So what that means is, we're finding the derivative at a. That a value happens to be e. Next, you're trying to figure out what the function is. And that's easy by taking a look at, this is the input. You're inputting that into f of x. So when you find the a plus h part, you can take this whole piece and replace it with x. And when you do that, it tells you what the function is. It's ln of x. So, the new question that you're being asked is, what is f prime of e of the function ln of x? Therefore, ln of x, f prime of x would be 1 over x times 1, which is just 1 over x. Therefore, f prime of e would be 1 over e. Once again, this we really didn't use. That's f of a, but because it was simplified, that's actually the ln of e. And the ln of e simplifies to 1, so if you didn't know what the function was, that 1 wouldn't be helpful. You're really going to use this term to help you identify what the function is and what the a value is. So you're taking a limit problem, turning it into a derivative problem.